Great morning, mini mathematicians. We're going to be filling in our notebook purpose. So please have out your notebooks and you'll be also getting a copy of the notes today. So filling this in for 4.3c, I'm going to pause the video for 2 minutes for you to fill in your lesson purpose. Please pause the video for 2 minutes. Okay, taking a look, our purpose today is we're going to solve inequalities and know when to flip your symbol. We've already talked about it a few times, but we're going to go into some other situations. So taking a look at the paper copy in front of you, multiplying by a negative when solving inequalities. Please follow along. We're going to look at this inequality. This is 4 is, what's that symbol mean, you guys? Oh, that's right, greater than 1. My question is that if I multiply both sides of the inequality by the same positive number, will this inequality statement, will the left side still be bigger than the right side? Why or why not? Well, let's take a look. Let's think about this. If 4 is greater than 1, what's a positive number I could multiply both sides by? 2, that sounds great. So if I multiply both sides by 2, using my parentheses here, is 8 still greater than 2? Yes. And that's because 2 groups of 4 is still more than 2 groups of 1. So that's why that's a true statement. However, if we're going to multiply both sides of an inequality by the same negative number, do you think we'll get the same result? Well, let's take a look. Again, if we have 4 is greater than 1, well, let's multiply both sides by negative 2. If I multiply both sides by negative 2, please write this down on your paper as well, I end up with a statement that negative 8 is greater than negative 2. Is this a true or a false statement? That's a false statement. This is not going to be true. That's because if I took away 2 groups of 4, that's more than taking away 2 groups of 1. So this is going to be a lesser number over here. To make this a true statement, I would need to flip my inequality symbol. So let's take a look at this table. It says, test your answers from above, where we think if you multiply by a positive number, we're going to have a true statement. But if you multiply by a negative number, we're going to have a false statement. We're going to complete the table by filling in the middle column with less than, greater than, or equal to. So let's take a look. 4 is greater than 1. Here we multiplied both sides by 2. So our new inequality is 8 is greater than 2. That's a true statement. Oh, if it's false, what can be done? Well, we don't have to worry about that here because it's true. Let's look at the next one. We multiplied both sides by 1, and we end up with 4 is greater than 1. Well, that's still true. Now we multiplied both sides by 0. What's 4 groups of 0? Oh, 0. Is 0 greater than 0? No, that is false. This is a false statement because 0 is not greater than 0. If we wanted to make this true, we would need to change symbol to an equals, or greater than or equal to, or less than or equal to, but we would need something about equals there. Let's look at the next one. We multiply both sides by a negative. What's 4 times negative 1? Negative 4. And 1 times negative 1? Negative 1. Is negative 4 greater than negative 1? Think about it on a number line. If a number is bigger on a number line, a number that's bigger on a number line is to the right. Well, negative 1's bigger than negative 4, so this is also a false statement. How could we change this to make the inequality true? We could flip the inequality symbol. Negative 4 is less than negative 1. That's how we would make this a true statement. Last one, we multiplied 4 by negative 2 and 1 by negative 2. We multiplied both sides by a negative here. So we ended up with negative 8 is greater than -2. False statement! We would want to flip the inequality because we know that -8 is less than -2. It's further to the left. So under what conditions did the inequality become false? So looking up here, it became false when we multiplied by 0 or multiplied by a negative. So what we need to say, when we multiplied by a negative or 0. When we multiply by a negative, it makes the opposite relationship. So now we're going to solve and graph the inequality. -2x is greater than or equal to 6, and we're going to explain our procedure as we go. So let's rewrite our problem over here. -2x is greater than or equal to 6. Our first step to isolate our variable is to undo multiplication with the multiplicative inverse. So we're going to multiply both sides by -1/2, or you could think about this as dividing both sides by -2. Are we multiplying or dividing by a negative? I like to circle my inequality symbol or highlight it to remind myself that I'm going to need to flip my inequality symbol because I'm going to have an opposite relationship. So I flip. And now I have x is less than or equal to -3. My variable's in front, and now I can graph. Remember, when we graph, we want to pick our boundary number, and we also want one number that is bigger. So one number to the right that's bigger than -3 is -2, and one number to the left that's smaller is -4. Should it be an open or closed circle at -3? Is -3 our boundary number included in our solution set? Yes, it is. So that's going to be a closed circle at -3. And which way should we shade? Are the solutions to the right bigger than our boundary number, or to the left smaller than our boundary number? This is x is less than or equal to, so we're shading to the left. Excellent. Great job. Let's look at the next one. Here we have x being divided by -3 is greater than or equal to -9. So I'm going to rewrite the inequality over here so I can show my work to solve. How do you undo dividing by -3? Oh, you would multiply both sides by, you got it, -3. I'm going to write it as -3 over 1 on this side just so I can deal with my fractions. These cancel out, and I am left with x. Oh my gosh, you guys, I'm multiplying by a negative, so I have to circle my inequality symbol so I remember to flip it. Taking the opposite relationship, So x is now less than or equal to, and -9 times -3 is a positive 27. Give your answer a box. Okay, so when I'm graphing this, again, we're going to have to graph 27. One number, one more bigger to the right would be 28, and one number, one more smaller to the left is 26. Open or closed circle at 27? That's right, it's closed, it's or equal to, it's included in our boundary. And are the answers to the right bigger or to the left smaller? This is x is less than or equal to, squishy L, 27, so we are going to shade to the left to be smaller. So let's finish our sentence here, and this is a big, the whole point of this lesson. It says, when you multiply or divide both sides of an inequality by the same negative number, that means when you're solving, circle your symbol, so you don't forget, circle your symbol to flip, you can say or switch, flip your inequality symbol. And that will help you remember not to forget. Super helpful. Circle your symbol to flip your inequality symbol. And that's really important. Whenever you're multiplying or dividing both sides by the same negative number. Great job, you guys. Okay, let's turn the page and we'll start working on 6 through 9. So let's track with me while I read the directions, please. Find the solution set for each inequality. Then graph the solution set. Scale the number lines appropriately, meaning we're showing our boundary number, one number bigger to the right and one number smaller to the left. So taking a look, our first goal is to isolate the variable. T is being multiplied by -5. How do I undo multiplying by -5? That's right, divide both sides by -5 or multiply both sides by -1/5. Am I dividing or multiplying by a negative? I am! Circle your inequality symbol so you don't forget to flip it. Negative divided by negative is a positive, so I'm left with 1t is now less than or equal to negative divided by negative is a positive 5. Variables in front, and I remembered to switch my inequality symbol. Let's start graphing. So I have 5, one number to the right that's bigger is, right, 6, and one number to the left that's smaller is, you're right, 4. Open or close circle at 5. Closed. Really good job. 5 is included in our boundary number. It's or equal to. And where are the answers? To the right bigger or to the left smaller? T is less than or equal to squishy L. So we're going to have our arrow go to the left. Cool. Let's look at the next one. 2y over 3 is greater than or equal to -4. Well, the first thing I need to do is get rid of that 3 in the denominator. So it's being divided by 3, so I'm going to multiply both sides by 3. Do I need to flip my inequality symbol? I mean, I'm multiplying by -4 over here. No, you don't have to flip your inequality symbol because you're not multiplying both sides by the same negative number to isolate your variable. So taking a look here, these 3's will cancel out, and I'm left with 2y is greater than or equal to -12. Now I need to still get y by itself. It's being multiplied by 2, so I'm going to divide both sides by 2. Do I need to flip my inequality symbol? No, I'm not dividing both sides by a negative. So 2 over 2 cancels out. I have y is greater than or equal to -6. Go ahead, give that a box. And we're going to start to graph this. Boundary number is -6. One number, one bigger, or adding 1 to the right is -5. And one number, one smaller, or subtracting 1 is -7 to the left. Open or close circle at -6. Closed. -6, our boundary number, is included in our solution set because it's or equal to. Should I shade to the right where they're bigger or shade to the left where they're smaller? This says y is greater than or equal to, so I'm going to shade to the right. Excellent. Please pause the video for 4 minutes and work on 8 and 9. Please pause the video for 4 minutes and work on 8 and 9. Thank you. Okay, thank you so much for your time. Multiplied both sides by 2 and got p is less than -8. Open circle at -8 and shaded to the left. Make sure your number line is labeled appropriately. Moving on to 9, 9 was a little bit trickier. Looking at 9, the first thing I needed to do was undo dividing by -4. To undo dividing by -4, I multiplied both sides by -4. Oh my gosh, I multiplied both sides by a negative. What do you need to make sure that you do? Flip your inequality symbol. That's why I circled or highlighted it. After I multiplied both sides by -4, I had y minus 3 is greater than or equal to -20. Because remember, I had to flip my inequality symbol because I made each side the opposite. Now I need to get y by itself. To undo subtracting 3, I added 3 to both sides to make a 0 pair. -20 plus 3 got me -17, so y is greater than or equal to 17. To graph that, I made a closed circle at -17, and I shaded to the right because that's where they are greater than. Perfect. Let's take a quick pause while we switch to the next video.